Good morning, Block 1 Math. As you know, I'm out today at a technology training slash workshop. So today you will take your notes with the video. Title 4.4, Scientific Notation, or 4-4 Scientific Notation. I can statement, I can express and compare numbers in scientific notation. I know scientific notation is not a new thing to you, but I do think a couple of things we're going to do are going to either be realizations or perhaps maybe new. Quickly, vocab, I have it down here for you. Obviously, you're taking notes right now, and you will pause and play and pause and play throughout this video as you are writing the notes into your 3-column notes. First of all, we have scientific notation. Scientific notation is the short way to show a number multiplied by a power of 10. Really quick, you're going to want to make this look a lot prettier than I am right now, but scientific notation could look like 2 times, a lot of times you see scientific notation with the multiplication sign, even though I don't like to use it, 2 times 10 to the 6th power. So anytime you have a number being multiplied by a power of 10, you have scientific notation. This number does have some parameters on it. We'll talk about it in a second. It can't be any number, and you'll realize that here, or you'll see that in a minute. Secondly, standard notation. You're going to see this on your assignment. That is the number written out using all applicable place values. So, for example, instead of writing 2 times 10 to the 6th, you're going to write what 2 times 10 to the 6th is. So it's going to be 2 with 6 zeros, so it's going to be 2 million. And that would be an example of a number in standard notation. Cheat sheet idea, you need to add it. We'll talk about these on Tuesday when I'm back in the classroom. Make sure you get your cheat sheet idea for main idea number 1. Sliding down to number 2, some must-knows in scientific notation. This is where I think a couple of realizations will come to you. We'll start with number 3. A number with a value less than 1 will have a negative exponent when written in scientific notation. So if the value of the number is less than 1, you're going to be dealing with a negative exponent. So the example I can provide for you is 2.7 times 10 to the negative 2nd. Most of you probably have learned or know that when you have a number and a negative exponent, that simply means you're moving the decimal point 2 places to the left. So if I take my decimal point and I know I have a negative exponent, or I see I have a negative exponent, I would slide it back 1, I would slide it back 2 places, put my decimal point there, insert a 0, and your answer is going to equal 0.027, or as you would say, 27 thousandths. So 27 thousandths. So if a negative exponent, you are going to move the decimal point 2 places to the left. To further prove that, if I have, I'm going to write kind of small here, and you should be writing this, 2 7/10 times 10 to the negative 2nd. You learned that when you have negative exponents, you need to try to get rid of them when multiplying. So 2 7/10 times 10 to the negative 2nd would really be times 1 over 10 squared. Put my denominator of 1 down here to make it look prettier. If you multiply this together, you have 2 7/10 times 10 squared is 100, or 2 7/10 over 100, which is 27 thousandths. 2.7 divided by 100 moves the decimal point 2 places to the left. So just a second way of proving to you what negative exponents are all about and how they apply to scientific notation. Again, hopefully you're making this a little prettier in your notes than what I did in mine here when you're showing the work here. Number 4, when multiplying a number by a negative exponent in scientific notation, move the decimal left the number of places expressed by the exponent. So I just, excuse me, I just did this. 2 7/10 times 10 squared, 1, 2 places over, put your decimal point, add zeros where you need to add zeros. The opposite, and this is, I think, something you would, you realize, I'm going to say equals 27 thousandths. The opposite would be, when I add a b here, 2 7/10 times 10 squared. No negative exponent in this situation, so we're going to move the number 1, 2 places, or the decimal 2 places to the right, and that equals, fill in your 0. We're talking about the number 270. 2.7 or 2 7/10 times 10 squared, which is really 100, gives you 270. So if you're multiplying by a negative exponent, you move left with the decimal. If you're multiplying by a positive exponent, you move right with the decimal. The realization here, or not the realization, but you need to remember if you don't already know this, the number being multiplied by the power of 10 in scientific notation must be 1 or greater but less than 10. So the example that I give you here is 10 and 1/10 times 10 to the 5th. This is not scientific notation because the number we're multiplying by 10 is 10.1. 10.1 is not less than 10. It is greater than 10. So scientific notation is never ever expressed with anything except a number that is greater than 1 but greater than or equal to 1 but less than 10. So the number's got to be greater than or equal to 1 but less than 10. I don't even know if I wrote that right. Greater than or equal to 1 but less than 10. Let's see here. So 10 and 1/10 times 10 to the 5th really has to be written, if you see this, 1 and 100th times 10 to the 6th. This is scientific notation, and it's going to give you the value for what you're intending the value to be in this one. Okay, as you notice, I moved the decimal point one place to the left, which puts it right here. So I moved it one place to the left, which puts it right there, which means I have to add an extra exponent, or an extra value, or an extra power of 10 to my scientific notation. Hopefully that makes sense. I feel like it's a little bit tricky. Quickly, your practice, we have 0.00709. If you're going to express that in scientific notation, we're going to move the decimal point 1, 2, 3, 4 places to the right so that we get a value that is 1 or greater but less than 10. So my value is 7 9/100 times 10 to the power. I moved it to the right 1, 2, 3, 4. Since I moved it to the right, it's going to be a positive exponent, so 10 to the 4th. 812 million, if I want to express that in scientific notation, you know the decimal point's right here, 812 million, the decimal point's going to be at the end of the problem. So you're going to move the decimal point 1, 2, 3, 4, 5, 6, 7, 8 places to the left. 8 and 12/100 times 10 to the -8th. Again, decimal point on a whole number is at the very end of that number. 1, 2, 3, 4, 5, 6, 7, 8. 8 and 12/100 is between 1 and 10, and that would be what would work. Last one, an oil rig can hoist 2,400,000 pounds. It distributes the weight evenly between 8 cables. Write the weight of each cable, or write the weight each cable can hold in scientific notation. So first of all, we have to figure out what is the weight, probably in standard notation. So 2,400,000 should be mental math for you. So we're getting 300,000 pounds per cable. That's not what the question asked, though. It asked you to express that weight in scientific notation. So here's my decimal point. 1, 2, 3, 4, 5. 3 times 10 to the 5th is, and this is going to be pounds, is my answer in scientific notation. 3.12 times 10 to the 5th. Or 3.10 times 10 to the 5th. Which tells me when I look back up here, I did something really wrong. If you look at number 6 and number 7, sorry, I'm trying to go too fast. I messed up on these. So let's go backwards and look at these. Number 6, we have 0.00709. We want to express that number in scientific notation. 7.09 times 10 to the 4th really means you're moving the decimal point this way 4 spots. Obviously, we don't want to move the decimal point that way 4 spots because that gives me a completely different value than this. So what we have to do is we have to realize what is it actually asking me to do? I asked you to express number 6 in scientific notation. The answer is going to be 7.09 times 10 to the -4th because when you convert that back into standard notation, you're going to want to move the decimal point 4 places to the left. So the same thing holds true for number 7. The answer is really 8.12 times 10 to the, this should be a positive 8. Sorry about this, you guys. But it's actually good because this mistake has been made a lot on final tests and quizzes. 8.12 times 10 to the 8th means we're moving the decimal point 8 places, whenever that is, to the right to give us the value of 812 million. So hopefully that makes sense and I didn't mess you up too much. When we come back to this, when we come back tomorrow, when I get back on Tuesday, we'll talk more about what that is all about. Good luck on the assignment. Make sure you get all your cheat sheet ideas down in each of the 3 categories.